Welcome back everybody, Patrick here, and moving on with another polynomial function question. We have to sketch this polynomial, negative bracket x plus 2 cubed, bracket x minus 1 squared, bracket x plus 5. We have to label all the x and y intercepts. So notice how this polynomial is in factored form, which is nice because getting those x-intercepts is going to be a lot easier. However, sometimes when it's in factored form, finding what the leading coefficient and the degree is a little bit more difficult. But in my opinion, it's worth the payoff versus having a polynomial in expanded form. Then you have to factor it, do the factor theorem, etc., to find those x-intercepts. So in my opinion, this is easier to work with. So let's go through some steps. So let's first find out what the degree of this polynomial is going to be. What you have to do is you have to picture it expanding this whole expression, which if you would try to do manually, it would take you forever. But you want to try to see what the highest exponent is going to be attached to the x. So notice how if we expand this polynomial, you'll end up having an x cubed somewhere, which would be the highest exponent. Here, the highest exponent would be x squared, and then here, the highest exponent is just this x, because the x plus 5 is just to the power of 1 here. So, if you multiply all of these out, same base, you're multiplying exponents, you add the exponents, so 3 plus 2 plus 1 would give us 6. So we know that this polynomial here, it has a degree of 6. Now, what about the leading coefficient? What's going to be the coefficient in front of that x to the power of 6? Well, what you want to do is you want to take any a value that's in front of a factored form polynomial. So here, notice how there's like this -1. And then what you want to do is you want to take all of the leading coefficients inside the brackets and take them to the power of whatever's up there. So notice how the leading coefficient here is 1 in front of the x, so it'll be like 1 to the power of 3. And there's a 1 here, so 1 to the power of 2. And there's a 1 here, which is like 1 to the power 1, which is just 1. So we went over this when we talked about factored form polynomials, how to find the degree, how to find the leading coefficient. This is actually a pretty simple form, but sometimes these forms can be more complex. So like maybe in this bracket, you can get something like 5 minus 2x to the power of 3. And then you can have like a negative a value again. And then it starts getting a little bit more complex because the degree is still pretty easy to find. Usually you're just adding up these exponents on top, but the leading coefficient can be tough to figure out sometimes, especially when you have stuff like this. You got to take that -2 to the power of 3 because that's the leading coefficient in the bracket. That would be negative, and then multiplying it by a negative a value in front would give you positive. So just because there's a negative a value, it doesn't mean that the leading coefficient is always going to be negative. So just be aware of that with more complex factored form polynomials. We go over a bunch of them in the lectures. So when you multiply all this out, you'll end up getting simply -1. So the leading coefficient is negative. So we have a degree of 6, leading coefficient is negative. So we already know what the end behaviors are going to be like. What about the x-intercepts? Well, the x-intercepts, again, because this is in factored form, they're pretty easy to figure out. So we got -2 here, +1, -5. So putting those in order from left to right, -5, -2, and +1. What about the y-intercept? The y-intercept is a little bit more difficult because we have to actually plug in 0 for x. When the polynomial is expanded, usually it's just that last value. When it's factored, we have to do some algebra. So 0 plus 2 is 2 to the power of 3. There's also this -1 still in front. 0 minus 1 is -1 squared, and then 0 plus 5 is 5 to the power of 1. So then doing all of the exponents first, 2 to the power of 3 is 8, -1 squared is 1, and then 5 is just like that. Multiplying all those out, we end up getting -40. So that is our y-intercept. And at this point, we're pretty good to go to graph this polynomial function with all of this information here. So first thing I do whenever I'm graphing is I always label the intercepts if possible. So notice how we are given, you know what, let's actually let's make this a little bit better, because we're given more x-intercepts on the negative side than on the positive side. So I'm going to make this negative side a little bit bigger. So we got -5 here, -2. Then we got +1, which is like here. And then y-intercept of -40, let's say it's like down here. And then what about the end behaviors? Well, the degree is 6, so it's an even degree. And then the leading coefficient is negative. So an even degree, negative leading coefficient, by this time you should know the end behaviors are going to be what? It's going to go from quadrant 3 and end off in quadrant 4. Another thing actually I just realized that I didn't mention with the x-intercepts is the order that they contain. So we can actually rewrite this. So this -5, kind of running out of room, I should have just wrote it initially. So the -5, it has an order of 1, so we can actually just leave that as is. We don't have to write anything. This -2 has an order 3. And then this 1 has an order 2. Right? And these are pretty important because it tells us what's the behavior going to be when we hit those x-intercepts on the graph. So this -5 has an order 1, so what's going to happen is the function is actually going to go through the -5. And then it's going to get to this x-intercept of -2, and because -2 has an order 3, that is an odd order. What does that mean? That means that the function goes through the x-intercept whenever there's an odd order. So like an odd order of 1, odd order of 3, function's always going through that x-intercept. And then it's going to get down to this -40. So whether it turns here or here, I'm not sure. We don't know that yet. We're actually going to figure that out in calculus in the next subject. But as long as you make it go through that y-intercept of -40, you should get full marks. And then it's going to come back up. It's going to hit this x-intercept of 1, but this 1 has an order of 2. And whenever there's an even order, what does that mean? It means the function is going to bounce off that x-intercept of 1 and then come back down. And that makes sense because it corresponds with our end behavior on the right side that we drew at the beginning. So this is how the function is going to look like. All of our x-intercepts are labeled, our y-intercept is labeled, and the end behaviors are from quadrant 3 to quadrant 4 because it's an even degree and a negative leading coefficient.